Okay, now let's look at the various abnormal pulses. And I'm going to teach you these abnormal pulses on the basis of pathologies. So in certain pathology, you have certain type of abnormal pulses, and in other pathologies, you get other type of abnormal pulses. Starting off with aortic stenosis. Okay, what is aortic stenosis? Aortic stenosis is the narrowing of the aortic valve. As a result, when the left ventricle contracts, only small amount of blood gets ejected out with each contraction, which results in either pulsus tardus or pulsus parvus et tardus, also referred to as pulsus anacroticus. Pulsus tardus. Tardus comes from the word tardy, which means late or slow. So what you get is a slow peaking, slow rising pulse. That is, the pulse rises slowly. It looks something like this. So the pulse rises slowly. It eventually reaches the peak, but then the rise is slow. It's a slow rising pulse. It reaches the peak, and from your normal pulse, you must know that the peak is the systolic blood pressure. What is the peak? The peak is the systolic blood pressure. Second is pulsus parvus et tardus, where parvus means low peaking. Tardus was slow rising, parvus is low peaking. Here you get low peaking, slow rising pulse, which looks something like this. So there is slow rise, plus the pulse never reaches the peak. It never reaches the maximum intensity. So there is slow rising and low peaking pulse. Since you have low peaking pulse, you get a low systolic blood pressure. Since you have a low systolic blood pressure, the difference between systolic blood pressure and the baseline representing the diastolic blood pressure is low. That is, the pulse pressure is low, less than 30 mm of Hg, which is referred to as low volume pulse. And that is why I asked you to remember low volume pulses to be seen in number 1, low output states, and number 2, stenotic valvular lesions like aortic stenosis and mitral stenosis. See, you can either use your common sense or the graph. Common sense is that since there is obstruction in the outflow of the left ventricle, when the left ventricle contracts, only small volume of blood gets squeezed out, giving us a low volume pulse. And the concept of graph is that since you get a low peaking pulse, the difference between systolic blood pressure and diastolic blood pressure is low as well, so giving us low volume pulse. Now, why slow rising? Why low peaking? Let's understand. You get a slow rising pulse because with each contraction, the ejection of volume of blood is very slow because there is obstruction. And you get a low peaking pulse because there is obstruction. So with each contraction, only small volume of blood gets ejected out. That means there is decrease in stroke volume and a decrease in systolic blood pressure. See, decrease in systolic blood pressure because there is decrease in stroke volume due to fixed obstruction present right here. Next is aortic regurgitation. Normally, when the left ventricle relaxes, the aortic valve shuts off, preventing the backflow of blood from aorta to ventricle. In aortic regurgitation, due to pathology of the aortic valve does not close at ventricular diastole. As a result, there is backflow of blood from aorta into the ventricle in ventricular diastole. So during ventricular diastole, the left ventricle is receiving blood from two places. One from backflow from aorta, another from left atrium. So it is filled with lots of blood. This lots of blood is going to push against the wall of the ventricle, which causes the left ventricle wall to stretch. And as per Starling force, the more the wall of the ventricle stretches, the strongly it contracts. So it's gonna contract strongly, and as the left ventricle contracts strongly, it's gonna push all that blood strongly out of the aorta to a long distance, giving us a sudden rising pulse, which is referred to as bounding pulse or Waterhammer pulse or Watson's pulse or pulsus sellis or collapsing pulse or Corrigan pulse. Okay, let me show you with the help of graph. So there is a sharp rise and a sharp fall. There is a sharp rise in pulse and a sharp fall in pulse. Since there is sharp rise, what do you have? You have a high systolic blood pressure. And when there is high systolic blood pressure, there is huge gap between baseline and systolic blood pressure, or pulse pressure is greater than 60 mm of Hg, giving us high volume pulse. And that is why I asked you to remember under high volume pulse two causes. Number one is high output state, and number two is regurgitant lesion of the heart like aortic regurgitation and mitral regurgitation. Okay, why the sharp rise and sharp fall? Sharp fall because when the ventricle goes through, arey bhai, this marks the end of systole. So this much is systole and this much is diastole. And during diastole, when the ventricle relaxes, it's receiving blood back from the aorta. The aortic valve does not sort of, so the blood, it falls back. So there is drop in the pressure inside the aorta. So there is a sharp fall. Once the ventricle is filled with lots of blood, it is going to contract strongly. So it squeezes out blood rapidly, giving us a sharp rise. That's why a sharp rise and a sharp fall in aortic regurgitation, which is referred to as a bounding pulse or Waterhammer pulse. Second, we can also see pulses Bisferiens. What is pulses Bisferiens? Very easy. Bis means 2. So there are 2 peaks in systole. 2 peaks in systole. See, here's the dicrotic notch, which marks the end of systole. So this much is systole. And in one systole, there's the first peak and then the second peak. Why? The first peak is as a result of percussion wave. Percussion wave is as a result of left ventricular contraction. And the second peak is as a result of tidal wave. So I mentioned tidal wave earlier. What is happening? The left ventricle is contracting strongly and the blood is getting squeezed out strongly, producing percussion wave. This wave strikes to the periphery and gets reflected back, and then the forward moving percussion wave and backward coming reflected wave hit one another, increase in intensity, producing tidal wave and the second peak. All of that is happening in the systole itself. Next is hypertrophic obstructive cardiomyopathy. Hypertrophic obstructive cardiomyopathy, there is hypertrophy of the wall of the ventricle, but the hypertrophy is asymmetrical, due to which there is more hypertrophy of the interventricular septum. Number one. Number two, in hypertrophic obstructive cardiomyopathy, the heart is hyperkinetic. That means it contracts vigorously. So now understand. Every time the left ventricle contracts, the hypertrophied interventricular septum, it shortens and bulges into the lumen. As it bulges into the lumen, it is going to cause obstruction to the left ventricular outflow. So there is left ventricular outflow obstruction every time the left ventricle contracts. This is hypertrophic obstructive cardiomyopathy. It gives us pulses Bisferiens. In pulses Bisferiens, what did we have? We had 2 peaks in systole itself. First peak and second peak. And you also get spike and dome. Spike and dome means there's a sudden rise in pressure and then plateau. Here is systole. Within the systole, there is your peak and then a dome. Now, why is there a peak and a dome? See, why is there a sort? I just said that it is going to obstruct the outflow. If it is obstructing the outflow, should it not be like aortic stenosis? Should there not have been pulsus tardus, pulsus parvus et tardus? No, because the obstruction here is dynamic. The obstruction in aortic stenosis was fixed. Dynamic means it is only when the ventricle contracts that the interventricular septum, it plops in and obstructs the outflow. So this is what happens during systole. The ventricle contracts, ventricular systole takes place during the very initial instant. Since you have a hyperkinetic heart, that is a strongly contracting heart, the blood gets pumped out very strongly, producing the peak. But immediately, due to shortening of the interventricular septum, there is obstruction of the left ventricular outflow, and then again you get a dome. So the peak is due to strong contraction by the hyperkinetic heart, and the dome is due to the obstruction by the shortening and plopping of the hypertrophied interventricular septum, giving us spike and dome or jerky pulse. Next is dilated cardiomyopathy, as well as in second week of typhoid, you get dicrotic pulse. In dilated cardiomyopathy, the ventricle is dilated and the heart is large in size. Plus, the heart is hypokinetic. Unlike HOCM, here is hypokinetic. Here you get pulsus dicroticus, which means there are two peaks. One peak, di means two. One peak is present in systole and the other peak is present in diastole. First peak and second peak. The first peak is as a result of percussion wave due to the contraction of the ventricle, and the second peak is as a result of exaggeration of dicrotic wave. See, if you remember your normal wave, this is what it looks like. Percussion wave, fall, dicrotic notch, and a dicrotic wave and a diastolic runoff. If I grab this dicrotic wave and produce it forward, will I not get a second peak? That is exactly what is happening here. So one is in systole and the other is in diastole. Next, left ventricular failure. Here also you get pulsus dicroticus. One peak in systole and the other peak in diastole due to the exaggeration of dicrotic wave. Systole, diastole, first peak, second peak. What you also get in left ventricular failure is pulsus alternans. In pulsus alternans, you have alternating high volume and a low volume pulse. Again, a high volume and a low volume pulse. The question is why? See, in left ventricular failure, some of the fibers of the left ventricle are normal, some of the fibers are deranged. Due to the normal fibers, you get high volume pulse. Due to the deranged fiber, you get low volume pulse, giving us alternating high volume, low volume, high volume, low volume pulse, also referred to as pulsus alternans. Finally, you have digoxin toxicity producing pulsus bigemini. This is pulsus bigemini. So there's your normal pulse. All of a sudden, at this point, you get ventricular premature contraction or ectopic beat, which produces secondary pulse. The same thing repeats after a pause. The same thing repeats after a pause. This pause is the compensatory pause. Compensatory pause. See, bigemini means twin, and your pulse has a twin. This is the pulse, this is the main pulse, and this is the second pulse due to ectopic beat. This is kind of like the twin of the main pulse. So you call it pulsus bigemini. Pulsus bigemini contains ventricular premature contraction, then compensatory pause, then ventricular premature contraction, compensatory pause, alternatively one by one. So those were the various pulses. Finally, you have pulsus paradoxus. I'll explain it in a while. First, let's revise all these pulses, okay? Let's revise them all. First, you had aortic stenosis with pulsus parvus and with pulsus tardus and pulsus. All right, let's revise all the abnormal pulses before getting into pulsus paradoxus. First, in aortic stenosis, you had pulsus tardus, which is a slow rising pulse. Number 2, pulsus parvus et tardus, which is a slow rising and a low peaking pulse, also referred to as pulsus anacroticus. Second, in aortic regurgitation, you had Waterhammer pulse or bounding pulse with a sharp rise and a sharp fall, and pulsus Bisferiens, which had two peaks in a single systole. Next, hypertrophic obstructive cardiomyopathy. It also had pulsus Bisferiens, that is two peaks in systole, as well as spike and dome, which contained a spike and a dome in the systole. Then, dilated cardiomyopathy. It had pulsus Dicroticus, that is one peak in systole and the other peak in diastole. Then left ventricular failure with pulsus dicroticus, one peak in systole, other peak in diastole, as well as pulsus alternans with alternating high volume, low volume pulse. Then in digoxin toxicity, we had pulsus bigemini with a normal pulse, then ventricular premature contraction giving us a tween of the pulse and then a compensatory pause. Again repeat. And then finally, in second week of enteric fever, typhoid fever, second week of typhoid fever, you had pulsus dicroticus as well. That is one peak in systole and the other peak in diastole. So those are the various abnormal pulses, right? Aortic stenosis, pulsus tardus, pulsus parvus et tardus, aortic regurgitation, the bounding pulse or Waterhammer pulse, and pulsus Bisferiens, hypertrophic obstructive cardiomyopathy with pulsus Bisferiens and spike and dome, dilated cardiomyopathy and second week of typhoid, pulsus Dicroticus, left ventricular failure with pulsus Dicroticus and pulsus alternans, and digoxin toxicity with pulsus bigemini. Then we have pulsus paradoxus, something that you really need to understand, a highly conceptual question and a topic with lots of viva questions.